Hey everyone, I'm Ramya, a developer advocate for AI and open source at NetApp InstaCluster. In this video, we are going to break down OpenSearch's other vector field type, sparse vector, and you'll know when to reach for it instead of knn vector. Quick note, if you have not seen my previous video on knn vector, watch that one first. Link is in the description. Let's go. In the knn vector video, we saw how dense semantic search lets users search by meaning. Powerful, but not the whole story. When users search for an exact product code, a specific medical term, or a precise technical term, dense semantic search can sometimes miss those, returning results that feel close but are terminologically wrong. That gap is exactly what sparse vector is designed to fill. Sparse vector is OpenSearch's field type for storing sparse neural embeddings. Each document is stored as a map of token weight pairs, the most important terms describing it, with a number for each showing how important that term is. That gives you interpretability. You can actually see which terms contributed to a match. 3 parameters to know. You can see them on screen now. The only supported method is seismic. End postings controls how many documents are retained per token, and approximate threshold controls when neural sparse knn search activates. The defaults work well to start. Let's see it in action. I'm using an OpenSearch cluster on NetApp InstaCluster managed platform. There is a video linked in the description that walks you through how to set one up. When you provision the cluster, make sure to enable the AI search plugin. That is what activates the neural sparse knn search features. Let's head into dashboards. Inside DevTools, 3 things to do. Create a sparse vector index, ingest documents, and run a neural sparse query. First, the index. This is the command to create the index. Here, we set index.sparse to true. This enables sparse search. Without it, sparse vector will not work. We define a myVector field of type sparse vector with the seismic method. End postings and approximate threshold will fall back to their defaults. Now, let's run the command. Here in the output, you could see that index is created. Next, we index 3 documents using the bulk API. This is the command. Here, each document has a myVector field with token weight pairs. The numbers like 10, 20, 30 are vocabulary tokens, and the numbers next to them are the weights. In production, you would pass your text through a sparse encoding model. Splade is a popular one, supported by the sentence transformers library. One critical thing, use the same sparse encoding model for indexing and querying. Different models produce different vocabularies, and your search will quietly stop working. Now, let's run the command. You could see in the output, all 3 are indexed. And now, the fun part, which is to run a neural sparse search query. This is the command. We are running a neural sparse query with 2 query tokens, token 10 with weight 1.0 and token 20 with weight 0.5. OpenSearch will score each document based on how well its token weights overlap with our query. Now, let's run the command. Here, document 1 comes back with the higher score. It shares both query tokens with high importance. Document 2 also matches but with a lower score. Higher score, better match. That is our neural sparse search pipeline, end to end. So when do you use which? Use knn vector for broad semantic understanding, RAG pipelines, recommendation systems, and conversational AI. Use sparse vector when term-level precision matters, e-commerce with exact product names, enterprise search with technical terminology, anything where missing an exact keyword breaks the result. These are complementary, not competing. Once you're comfortable with both, explore hybrid search in OpenSearch, which combines traditional keyword search with dense semantic search in a single pipeline. 3 quick takeaways. 1. Sparse vector adds a precision layer by storing token weight pairs that preserve the importance of specific terms. 2. Seismic power sit under the hood and the defaults work well to start. 3. Use k-NN vector for meaning, sparse vector for precision, and explore hybrid search to combine keyword and semantic retrieval. If you want to go deeper, the full blog article is linked in the description. And if you want to try this yourself, spin up a free OpenSearch cluster on NetApp Insta Cluster. That link is also below. If this was helpful, give it a like and subscribe. Thanks for watching.